A very warm welcome to one and all. I'm Professor M.S. Patil, Department of Mechanical Engineering. Today, I'm going to talk about different types of stresses that are used in the design of machine components. It will be just the revision of what we have studied in strength of materials in the earlier semesters. So starting with the learning objectives. The learning objectives for today's session will be starting with types of loads. What are the different types of loads to which the machine components is subjected to? And what is the effect of those types of loads on the component? Then we will talk about what is stress and what is the difference between stress and strength of material. Then we will talk about the different types of stresses that will be used for calculating the dimensions of the machine component. Starting with different types of loads. Basically, there are three types of loads which are used for the designing. But when we are talking about a load, we mean the forces which the machine component will be subjected to. We mean the bending moments to which the machine component will be subjected to. And we mean about the torques to which the machine component will be subjected to. That means the load is a broad term which includes forces, bending moments, and the torsional moments or torques. Loads are basically classified into three types. Those are static load, fluctuating load, and impact load. Static load is the load in which the magnitude of the load and direction of the load and the point of application, or all of the three, always remains unchanged. Then that type of load is called as static loading. When we talk about magnitude, that means we talk about the value of the force. That means 50 Newton, 100 Newton, it won't change. When we are talking about direction, then direction means it can be tensile in nature or it can be compressive in nature. It won't change. Then if all the three remains unchanged, then we say that the type of load is the static load. Second type of load is fluctuating load. Fluctuating load is the load in which the magnitude and or direction and or point of application changes with respect to time. Then that kind of load is called as fluctuating load. The best example for the fluctuating load is the loads acting on the springs which are used in the suspension system. The springs are subjected to loads of variable magnitude and changing directions. Then that type of loads are called as fluctuating load. The third type of loading condition is of impact load. When the load is applied suddenly with a certain velocity, then that type of load is called as impact load. The example of impact load may be a dropping object from a certain height. Then that kind of load will be called as the impact load. Now, after finishing with load, we will talk about stresses. What is stress? Stress is something which is induced in the material due to the action of external forces. Or we can say that it is nothing but a resisting force which is set up within the component due to the action of external forces. That is termed as stress, and mathematically we can calculate it as force per unit area of the component, or the internal resisting force per unit area of the component is called as stress. Stress will be denoted by sigma, tau, and stresses can be axial stresses, tensile or compressive in nature. When the forces are acting along the axis, then the stresses induced are called as axial stresses. If the forces acting on the machine component, if they are tangential, then the stresses induced are called as direct stresses or torsional shear stresses. If the forces acting on the mechanical component are such that they tend to bend the object, then that type of forces are called as that type of stresses are called as bending stresses. Best example of bending stresses are the stresses to which the beams are subjected or shafts are subjected. Then the stresses can be crushing stresses or bearing pressure. Basically, crushing stresses or bearing pressure are localized compressive stresses, and they get induced in the material when two mechanical components are always in contact with each other. So these are stresses. But what is the basic difference between stress and strength of the component? See, stress is induced in the material due to action of external forces. That means when forces are acting on mechanical component, then stress will be induced. If no forces, no stresses will be induced. But strength is something which is related to the property. So we can call strength as the property of the material. And for the safety of the component, stresses which are induced due to action of external forces should be always less than the strength of material. Strength can be evaluated or tested by carrying certain tests. For example, if we carry simple tension test, then we can obtain the value of yield stress and ultimate stress on ductile material, or only ultimate stress in case of brittle material. Then yield stress or ultimate stress, they are nothing but the strength of the material, while when the component is subjected to external forces, stresses get induced, and stresses should be always less than the strength of the material. Now talking about different types of stresses. First type of stress is tensile stress. When a mechanical component is subjected to a pull force along the axis of the component, then the induced stress is called as direct stress, and the nature is tensile. So you can call it as tensile direct stress or tensile stress, and we can calculate tensile stress, which is denoted by sigma T, as force upon area. Force P is the external force in Newton, and A is the cross-sectional area in mm square. So the unit will be Newton per mm square. If the cross-sectional area is in meter square, then it will be Newton per meter square. If the forces are such that they tend to shorten the member, that means push force, then the type of stress induced is called as compressive stress. And again, compressive stress can be calculated using the same relation as sigma C is equal to force upon area. We have seen it in tensile stress also. Sigma T is also equal to force upon area. That means the relations are same. Third is the direct shear stress. Direct shear stress is the stress when the external force acting on the component tends to slide the adjacent plane with respect to each other. Then that type of stress will be called as direct shear stress. Consider an example of a riveted joint. One plate, second plate. These two plates are joined with the help of a rivet, and a tangential force is applied. This force, this P and this P, will shear off the rivet over here, which we can see over here, right? Therefore, this is the shear plane, and the stress is the direct shear stress, which can be denoted by tau and calculated as tau is equal to force upon area. Shear stresses can be single shear or double shear. Such type of stress, which is shown in figure, is single shear. If there is one more plate and the rivet is joining all these three plates together, then there will be two shear planes, and the shear stress induced will be called as double shear. Next type of stress is torsional shear stress. Torsional shear stress is induced in the material when the component is subjected to torques, external torques. Then that type of stresses induced will tend to twist the material, and therefore those stresses are called as torsional shear stresses, which can be evaluated using torsion formula. Mt upon J is equal to tau upon R, which can be rewrite as tau is equal to Mt into R upon J. Mt is the torsional moment or torque, R is the radius, and J is the polar moment of inertia. Next type of stress is the bending stress. Bending stress is something which tends to bend the material It can be compressive in nature or tensile in nature based on the condition of the beam. For example, if you're talking about a simply supported beam and subjected to a point load or UDL from the top, then the top fibers will be subjected to compression and bottom fiber will be tension. And this will be exact opposite when the beam will be treated as a cantilever. Bending stresses can be calculated using flexural formula M upon I is equal to sigma upon Y, and rewriting the things, we can obtain the formula for bending stress. Sigma B is equal to M into Y upon I, where M is the bending moment. Y is the distance of extreme fiber from neutral axis. Neutral axis is something which is neither in compression nor in tension. And I is the moment of inertia about the neutral axis. Next type of stresses are crushing stresses and bearing pressure. These are localized compressive stresses at the area contact between two mechanical components which are always in contact with each other. Then that kind of stress can be either crushing stress or bearing pressure. You can see over here in this figure, a shaft is rotating in a bearing, or a shaft is supported by a bearing rather. Diameter of shaft is D and L. That means D of shaft and L of the bearing, they are always in contact with each other. That means the projected area. Then that kind of stress induced is crushing stress or bearing pressure. Now, when to consider crushing stress and when to consider bearing pressure? When two mechanical components which are always in contact with each other are not having relative motion. This is most important thing, not having relative motion. That means if the shaft is stationary in the bearing, that means there is no relative motion, then that type of stress will be crushing stress. And if they are having relative motion, that means this shaft is rotating inside the bearing, then the stress induced will be called as the bearing pressure, and both can be calculated using the relation force upon projected area of contact. Note, it should be noted over here, it is projected area of contact. In other type of stresses, it is cross-sectional area. Here the projected area is the area to which they are in contact. That means D into L in this case. So P upon D into L will be bearing pressure or crushing stress. No relative motion, then crushing stress. For example, keys. If there is relative motion in case of splines, then the design criteria will be bearing pressure. And talking about the unit of stress, basic unit is Newton per meter square, also called as Pascal. It can be kilopascal, it can be megapascal, or it can be gigapascal. Kilopascal 10 raised to 3 Pascal, megapascal 10 raised to 6 Pascal, or gigapascal 10 raised to 9 Pascal. But most commonly we have to convert megapascal into Newton per mm square. So how to convert megapascal into Newton per mm square? Megapascal is 10 raised to 6 Pascal. That means 10 raised to 6 Newton per meter square, as Pascal is equal to Newton per meter square. But 1 meter square is equal to 10 raised to 6 mm square. So 10 raised to 6, 10 raised to 6 will get cancelled out, and we get 1 megapascal is equal to 1 Newton per mm square. Similarly, gigapascal can be obtained. So this is the unit of the stress which will be commonly used. So today in this session, we have studied about different types of loads, different types of stresses, and how to calculate different types of stresses. In the next session, we will be talking about the design of simple mechanical components. Thank you for now.